Hi, I'm Sifi. I talk to researchers about what drives them and what they're passionate about. What's your name and what are you currently studying?
So I'm Sam Rose. I'm a grad student at Caltech in the Astronomy department, where I mostly work on supernova explosions. So the ends of lives of very massive stars, more than about 10 times the mass of our sun, will end their lives in these spectacular explosions. And I watch these go off all across the universe and try to understand where they come from and exactly what effect they have on the environments around them.
What's a project you're currently working on that you're really passionate about?
Something I'm really excited about right now is working on sort of the lowest luminosity, faintest kinds of explosions that we see in the universe and how those explosions make space dust. So space dust is not the kind of dust you find in the corners of your house, but the kinds of stuff that goes on to form planets. So chunks of silicates, stuff that makes up sand, or chunks of carbon, which will later go on and stick together and start to form bigger and bigger pieces of material, which ultimately might become a planet if it goes around the star. So just trying to understand the origin of that dust is something I'm really excited about.
In what ways do you see your research making an impact in this world?
As an astronomer, our work has very few real world applications. A lot of our process work does actually lead to dramatic improvements in life. So it was actually a radio astronomer who invented the technology for Wi-Fi, just as a sort of a way to deal with his data at the time. But the direct science benefit of knowing exactly, this kind of explosion makes this much dust of this kind is less important, I think, for everyday life from a very practical perspective. But I think understanding our cosmic origins, right? Planet Earth is just a bunch of dust particles that got stuck together. Understanding a little bit about how that got there, how we got here, I think is really powerful and really just cool thing for humans to work about and think about.
What's your process when you're trying to learn something new or come up with new ideas?
Yeah, I think it was Isaac Newton who said, we do science, we stand on the shoulders of giants. And I think that's basically every idea has its roots in another idea that someone else had once. We're very much a specialization species, which requires understanding the knowledge that has sort of been passed down before. So if I'm trying to come up with a new idea, the first thing I do is I just look and see what's there already. I encounter a new subject and I really try to read papers about that subject, or if there's any kind of book that's been written about it, just to really understand exactly what we have. And that is what gives you the ideas to go in a new direction. It's really hard to sort of come up with things in a vacuum.
Which single habit do you think has contributed most to you?
I think it's just making a habit of being curious. Like whenever I hear something new or I go to a talk and I hear something I don't quite understand, it's the desire just to look it up and find out more about it. I've learned so much that way, not just about my research, but about other things. And I think just being curious, it's really a good habit to cultivate to be a good scientist. And really I think it helps, makes you a more interesting person, a more happier person if you're learning things about the world.
Who is your supervisor and how have they influenced or shaped your academic journey?
I'm advised by Professor Monse Kazuo in the Astronomy department here at Caltech. She is so fantastic. She has helped me sort of figure out exactly what it is I want to do. Great at not just communicating ideas, but also figuring out what questions are important to ask. That's sometimes the hardest part in science, is not actually doing the science, not actually trying to answer the questions, but knowing what questions you should ask in the first place. What are the ones that are timely based on the kinds of resources you have available to you? What are the kinds of questions that are interesting right now that people haven't explored yet? And she's really good at that, and sort of figuring out exactly what direction you should take your research in a way that'll make it not just interesting to you, but interesting to the community as a whole, and also make it plausible that you can actually do it. I think gravitational waves were predicted in very early in Einstein's general theory of relativity, but they weren't detected until 2015, nearly 100 years after they were first predicted. So.
What are the primary sources of funding for your research?
Yes, I get a lot of funding through space telescope proposals. So NASA, when you write a space telescope proposal, for example, for James Webb Space Telescope or for the Hubble Space Telescope, along with that comes a certain amount of money to undertake the analysis and do things like pay grad students and stuff. So a lot of the funding that pays me specifically comes from James Webb Space Telescope proposals that I've written, that my collaborators have written and been awarded funding for. So mostly through the public sphere.
How do you typically find yourself meeting new people around campus?
Yeah, this is something I struggle with. I definitely spend a lot of time with the astronomers and in astronomy. One of the ways I really meet new people is I really enjoy doing outreach. So I spend a lot of time setting up telescopes and getting to meet people through that.
What's the best advice someone has given you?
I'm someone who sort of struggles with finishing things. I never feel like something is quite good enough where I want to share it with other people. This is especially a challenge when you're publishing research papers. I always feel like there's more analysis I want to do, there's more things I want to add, but that means that you never quite finish anything. So sort of the best advice I've ever gotten is from my advisor at Berkeley, Professor Jessica Liu, which was to stop polishing cannonballs. Sometimes something is good enough for what it needs to do, and there's no point in making it shiny and perfect when, an unshined cannonball will do just as well as a shiny one.
What's one question about the universe you hope humanity finds the answer to in your lifetime?
There's sort of broader ones that I can pick, but I think this one we have a very reasonable chance of finding out. There are a class of explosions that we see in space called intermediate luminosity red transients. They are fairly red in color and they're fairly low luminosity. And it's not entirely clear what causes them. There are some ideas that they might be the result of two stars merging together, or they might be the result of a star blowing away its outer layers, or they could be an example of something called an electron capture supernova. I'd be really curious to find out exactly which of these three things these ILRTs are. My personal feeling is I think that they're electron capture supernova. And this is something we could definitely figure out probably in the next 5 years.
Has studying such vast universe changed the way you look at everyday life?
I think yes and no. Obviously, when you start to think about these incredible vast scales, the importance of Earth, the importance of humanity is somewhat diminished in the face of that. It definitely sometimes puts, your everyday life into perspective. But for the most part, my problems are my problems and they're important to me. So maybe if they're not important to the universe, that doesn't matter so much. I think spending time thinking about those incredible distances, it makes me, I think, more proud to be a human and more proud to be a member of such a small species, because we're still as much a part of the universe as everything else around us. We are the universe arranged in such a way that it can kind of help to understand itself. It can ask questions about itself and try to really understand what's going on with it. So I sort of look at it as we're just a tiny part of the universe getting to experience some self-discovery.
What's one skill you think everyone would benefit from learning? Something that shaped your life and research journey as well?
Oh, I think being able to ask stupid questions. This was something I sort of struggled with as an undergrad. I dealt with a lot of imposter syndrome. I was very afraid to ask questions in class or ask questions in lecture or ask questions at a talk for fear of sounding stupid, because the question wasn't very good. But that's not a great way to learn. It's not very productive. If sometimes questions are stupid, but you still need the answer to them in order to progress. And sometimes what you think is a stupid question is maybe actually a good question. So you should really just ask it, sort of trying to get over that sense of trying to impress others, right? You really are just trying to learn. And people aren't as judgmental as you think.
When you come across complex concepts or ideas, how do you break it down into smaller, easy to learn and actionable steps?
This is something I'm still learning how to do, I think. It's easy to see a big task and get overwhelmed and have a difficulty starting. Sometimes what I do is it's easier to start something I think is going to be really hard if I promise myself that I'll just do it for an hour. And if I just start, then things start to become more clear and it sort of tends to naturally break itself up. And I end up working a lot longer that initial hour. But yeah, definitely looking at you have to put some work into order to chuck things to begin with. And sometimes that first step is really hard to take, but just taking the first step really helps.
What fun advice would you give to students who want to pursue this job?
If you are currently an undergrad, you should try to take as many physics and astronomy classes as are available to you. Most of our work these days is on computers, so learning very basic programming skills will be very valuable for you. I think especially machine learning, big data sets are definitely the way that astronomy is moving. We are getting bigger and bigger telescopes, which are looking further and further and seeing more and more things. So being able to deal with those large data sets in a way that's very clever. If you have the opportunity to do research, that's the most helpful thing you could do to apply for grad school and really understand what grad school is about, because grad school is actually very different than just like taking classes and something. Most of your time will be spent doing research. For example, I'm in my 4th year now. I don't take classes anymore. I just do research full time. So if you don't like research, you will not be very happy. It's good to figure that out sooner rather than later.
That was great. Thank you so much.